Welcome to Easy Math TV. This is a continuation of our Introduction to Probability and Statistics, and we're going to talk about the most important continuous distribution in statistics, which is called the standard normal distribution. In front of you is a picture of it. With any continuous probability distribution, there's always a curve that shows which outcomes are more likely, which outcomes are least likely. So you don't need to know the formula for this curve. We don't even need to know what the y values are. We just need to see that there is kind of a hump. It's a bell shape. We call it a bell-shaped curve. The distribution has a name that is named after the person who discovered it. You might hear people call it the Gaussian distribution, but that name is being less and less used because it's not very descriptive of the curve. Calling it a bell curve is a little more descriptive. But it's what we call a normal distribution, and in a few in a few chapters, or maybe it's the next chapter, you're going to learn about something called the central limit theorem, which is why we care about the standard normal distribution. And what it means is that these values that you see on the horizontal axis that go from -3 to +3, that are marked from -3 to +3, and they actually continue on further in both directions, but we become less and less interested in values that are further to the left and further to the right, because at some point you get things that are just so unlikely to occur that the probability is almost zero. So we're really only concerned about values that have a measurable probability of occurring, and that takes us somewhere between, you could even extend this to -4 to +4, and that would give you things that like have a non-zero probability. But we're going to set up our table here with z-scores or z-values from -3 to +3. So imagine that you're just graphing a function and you set x to be values from -3 to 3. That's basically what we're doing here. But instead of calculating y values from a formula, we don't even have an equation, but we do have a built-in function in Excel that will give us these probabilities for us. And on the picture that you see in front of you, what we're seeing pictured here in orange, this is the probability of an outcome z being less than 1. So we are concerned with areas under the curve. That's basically what we're interested in. So we don't care about the actual y values of the curve. We care about the areas of the curve, okay? So that's what we're going to be calculating here in a moment. And I just wanted to give you a picture to show like what it is we're actually discussing. We're talking about probabilities of continuous random variable, and those probabilities are represented by areas under the curve, and this is a very special continuous random variable called the standard normal distribution. Okay? So in column B, we have our z values just typed in there, and I have it highlighted in yellow for a reason you'll see later. You won't see it in this video, you'll see it in another video. But I just want to establish what all of these probabilities are. So set up our probability table here. These are not frequencies. These are not relative frequencies. These are cumulative frequencies, because you can only do relative frequencies if your outcomes x are discrete. We don't have discrete values here. So there is no such thing as a relative frequency, but there is such a thing as a cumulative relative frequency or a cumulative probability. So column C is our cumulative probabilities for values of z being less than this number that you see here in column B. So what's the probability of z being less than -3? And that's the number that you see here. What is the probability of z being less than -2? That's the number you see here, okay, in C3. And you'll notice that these numbers are getting larger as we go because we're moving farther and farther to the right. And so the total area to the left is going to be a bigger number. You know, that just makes sense. The larger the z value, the larger the probability will be to the left of that value. So the number in C2, we're going to use the built-in function in Excel called norm.s.dist. So the capital S there is for standard normal. There are ways of calculating normal probabilities without using z values if you happen to not know the z value. But this is for the standard normal distribution. So it's equals norm.s.dist and then parenthesis, and then we want the number that's in B2, that's our z value, comma, and then we want to type in the word true because we are calculating a cumulative probability. It's the total probability of any outcome less than -3. And that's really small. So you'll notice that that's less than 1%. So if we move the decimal point over 2 places, it's literally 0.13%, or 13 out of 10,000. So 13 out of 10,000 outcomes will be less than -3. That's pretty rare. So I filled it down, so you'll just see that norm.s.dist function keeps appearing in all of these cells going down column C, and it's giving us the cumulative probability for the value that you see in column B there. So if you don't want to type those in individually, move your mouse down to the anchor in the lower right corner of cell C2 and just fill down. I've highlighted the number that you see here in C6, and I've colored it in orange because that is the probability that is shown in the graph, because that's the one associated with a z-score of +1, right? So when z is equal to +1, the total probability of anything occurring to the left of that is 0.8413, or 84.13% of the time. So z-scores are just numbers. They represent standard deviations from the mean. So there are very specific probabilities associated with those outcomes. Since z values measure units in standard deviations from the mean, there's a very specific probability that occurs with or that happens with each of these outcomes here. So for example, if we had z equals 1.5, because you can take on any integer or decimal value at all. So z values can extend from -infinity to +infinity, right? It's continuous. So it can be any decimal value at all. So if we had z equals 1.5, we would interpret that as 1.5 standard deviations above the mean. That's what that number means or represents. So let's also calculate, since we're in the process of calculating probabilities, let's also calculate the probability to the right of a z-score. So that would be the white area that you see down here. In fact, let's go to insert. I'm going to insert a text box here, and I'm just going to type in probability of z greater than 1. Close parenthesis. So that's the white portion that you see down there. Okay? So the white portion is the probability of z being greater than 1. The orange portion is the probability of z being less than 1. So let's calculate all of those probabilities to the right. And we're just going to use the complement rule there. So in cell D2, type equals 1 minus C2. Again, in cell D2, we're going to use the complement rule. And we're going to use the fact that those two portions here on this picture, the orange and the white, have to add up to 1. So in cell D2, it's equals 1 minus C2. Hit enter, and then you can click on that anchor in the lower corner and fill those numbers down. So you should notice that these values here in column D are the exact reverse of the values in column C, because we're not looking at it from the left anymore, we're looking at it from the right. Let's do one more thing, and then we'll stop here, and then we'll take it up in our next video. Let's calculate the probability between two values of z. So you can see that pictured down here in this middle picture. I have two z-scores or two z-values just kind of randomly pictured, and the probability of an outcome being between those two values. We're going to calculate those. So in column E, those are my descriptions. So anytime you're between two values, if you want to type a negative sign in the cell as a text and not have Excel treat it as a formula, you need to type an apostrophe there in front of the negative sign. I'm just giving you that as a heads up. So these are just labels. So, this is not a formula. This is just a label. And the first character, the first thing that I want displayed is a negative sign. So I have to hit apostrophe, -3 and -2. And that's basically describing this is the probability of events or outcomes between z equals -3 and z equals -2. That's what's happening in row 2 here. So to calculate that probability, let's go over here to column F. This is the probability that z is in between two numbers. So we're literally going to subtract. We're going to type equals, and we're going to take the number from C3, which was the probability to the left of -2, and subtract C2, the probability to the left of Z3. That's going to give us the area in between. So equals C3 minus C2. That's going into column F in cell F2 here. So that's the probability of an outcome between -3 standard deviations and -2 standard deviations, which is a little over 2%, 2.14% of the time. So it's a bit on the rare side. It's not going to happen very often. However, when we move closer to the middle, let's look at between z equals -2 and z equals -1. That's calculated here in F3. But again, you can just click on that anchor again. Here's the anchor at the lower corner of F2, and just fill that down. So the last thing we're calculating is between z equals +2 and z equals +3. So you can see some of the symmetry happening here. Like these two numbers are exactly the same. When you go between -2 and -1, that's 0.1359, and that's exactly the same as between 1 and 2. That's 0.1359. So there's your symmetry. There's your symmetry going on. So let's stop there. Those are just calculating our probabilities. That's all we did. We're not really we haven't really talked about how to understand them yet or how to use them. But so it what we have done though is that we have managed to calculate all of the probabilities that we're going to be needing. And in the next video, we'll solve some example questions or solve some example problems having to do with that. Okay? Like, subscribe, comment down below, share these videos with other people if you think they'll find them useful, and I'll see you in the next video.